We rarely think much about the electricity we use. It's just there when we want it. Flip a light switch and there it is. Press the button on your TV remote and action. But when we flip a switch and nothing happens, well, that's when we realize we're not really in control after all. Ultimately, we're all part of the interconnected nationwide system known as the grid. But imagine generating your own electricity independent of the grid, like your own mini substation. This rather nondescript little object could make it a reality. It's called a fuel cell, and some experts think it's the green, clean energy source we need.
This is the first generation, interestingly, called AP1.
Chris Guzzi is the Chief Technology Officer for Ballard, a Canadian-based fuel cell manufacturer. His company is developing fuel cell systems for homes in Japan. So literally somebody might have one of these in their home in Japan and be off the grid.
No, in Japan it's used, it's grid powered, and what it's used for is to balance hot water heating and electricity.
So it's working with the grid?
It's working with the grid.
But is it possible that someone could have one of these and then be off the grid?
Sure.
Entirely?
Yeah, if it was big enough. And
that's where size matters. The larger the fuel cell, the greater the output of power. Most fuel cell systems designed for home use can generate up to 2.5 to 5 kilowatts of electricity. But before we talk about the wonders of this technology, let's first find out exactly how they work. Basically, a fuel cell converts chemical energy into electrical energy. In this case, it converts the chemicals hydrogen and oxygen into water. Electricity is produced in the process. But using pure hydrogen is a huge challenge. It's expensive and difficult to store. Even though it's all around us, hydrogen is never found by itself. It's always combined with other elements. So to be used in a fuel cell, hydrogen has to be extracted from sources like natural gas, methanol, or gasoline. The process is called reforming. Fuel cells do provide a steady stream of power. They have no moving parts, release low amounts of CO2, and the main byproduct is water. So why is something with such green appeal not being found in every backyard?
Cost, and cost. There aren't any inexpensive fuel cells.
That's especially true for fuel cells where the catalyst is platinum. It's a pricey element found mainly in Russia and South Africa.
We need to come up with a substitute for platinum, but that's much easier said than done.
For researchers like Elton Cairns from the University of California at Berkeley, fuel cells have seen varying degrees of praise and rejection.
2, 1, 0.
Their most notable boost came from the Gemini space program in the 1960s.
They were used to provide the electricity for all of the instrumentation on the spacecraft. As a byproduct, they were used to provide drinking water for the astronauts. I would like to see fuel cells used much more widely for powering stationary systems.
To a degree, that's already happening. Connecticut-based UTC Power supplies fuel cell systems to several companies. This Coca-Cola bottling plant in New York gets 35% of its power from them. And this Verizon data center, also in New York, counts on fuel cells as a reliable source of backup power. The fuel source for these systems is natural gas. But then there's Bloom Energy. The company has given fuel cells a major PR boost with its release of the Bloom Box.
This would power an average U.S. home. 24/7, 365.
Like Grandma's secret recipe, it's the ingredients that make the difference.
The core of our technology simply is sand.
The cell is made of ceramic material, and the catalyst is made from special ink. It can use natural gas or biogas. Stack a bunch of these together, and you've got the Bloom Energy Server. Take a trip to eBay's corporate campus in San Jose, California, and you'll see several of these SUV-sized boxes on the ground. eBay officials say the servers give them 15% of their power off the grid. But they're not cheap. Each box runs just under $1 million. But wait, the technology can go even further. Quite literally. Take this remote community of Bella Coola Valley in British Columbia. It gets power from a hydroelectric dam, but finds it still needs more. Stringing power lines just isn't practical, so how do they get the extra juice? Diesel generators. The downside, it spews a lot of CO2 into the air, so enter fuel cells. Although here, a different method generates the hydrogen, electrolysis.
Hydrogen from electrolysis is a clean source of hydrogen where no CO2 is emitted because you're using, say, wind or solar to power the chemical reaction.
But this is a pilot-scale project, and there are technical issues to be addressed. But think of countless villages and communities that may one day trade in those noisy, smelly diesel generators for silent, clean fuel cell power. One organization that sees the benefits knows a thing or two about being green. Here at the Army's Research Lab in Adelphi, Maryland, Chief Electrochemist Cynthia Lundgren fires up a rudimentary fuel cell powered by less than half a thimble of methanol.
So now what little bit of methanol we put in there were like 6-7 drops. We'll run this thing for about 11 hours.
11 hours?
Yeah, that's how long we've tested it.
Get the picture? For the Army, one of the biggest draws of fuel cells is the lighter weight to pack around compared to standard batteries. And in combat situations, they provide improved stealth, giving off lower heat and noise signatures. But the reality is that none of these fuel cell technologies are officially deployed right now. Like many fuel cell applications, they remain in a testing phase. For now, most of us will have to stay connected to the grid. And while fuel cells may not be ready for prime time, it may not be too long before that iPod of yours is running off, a fuel cell. For Energy Now, I'm Daniel Seberg.